Welcome to an intro to reduction of order. So the idea here is if we want to solve a generic second order linear differential equation. So let's say we want to solve P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y is equal to f of x. If we know one solution to the homogeneous equation, one non-trivial solution, so if we know one non-trivial solution to the corresponding homogeneous equation, which we'll call y1 for our solution, then what we will do is we will assume that y is equal to u times y1 for some function u of x. So this should look somewhat similar to variation of parameters and a whole variety of sort of forms we've done this with. We actually used reduction of order for the case where we had constant coefficients with a repeated root for our characteristic equation. This assuming y equals u times some other solution is a standard technique to use. So the general process. So again, we're going to assume that, or we have a solution y1 to the equation P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y equals 0. Then we are going to assume y equals u times y1 is a solution to the original equation P0 of x times y double prime plus P1 of x times y prime plus P2 of x times y is equal to f of x. So we are going to find the derivatives of y and plug it into the equation. So we will find y, y prime, and y double prime, and plug these in. To the equation. So we have y is u times y1. Y prime is u prime times y1 plus u times y1 prime. And the second derivative, y double prime, is u double prime times y1, plus we will wind up with 2 copies of u prime times y1 prime. That's the second half of the product rule from the first term, plus the first half of the product rule from the second term. And then we will have our last term, u times y1 double prime. So if we plug these in, we have P0 of x times our y double prime, so u double prime times y1, plus 2u prime times y1 prime, plus u times y1 double prime. That's our first piece of our equation. Then we will have plus P1 of x times y prime. So we have u prime y1 plus u times y1 prime plus P0 of x times y. So plus P0 of x times u times y1. This whole thing should equal f of x. If we rearrange this, so we have our u double prime, and u as separate terms. So rearranging this, we have our u double prime is a p0 of x times y1 times u double prime. For u prime, we will have 2 times p0 of x times y1 prime. And we will also have a p1 of x times times y1. All of these multiply u prime. So our first term here just came from p of 0 times u double prime times y1. Our second term, we are looking at, we have p of 0x times 2u prime times y1 prime. And then we have a p1 of x times u prime times y1. And then our u term, we will have plus, we have p0 of x times u1 times y1 double prime. So we should have a p0 of x times y1 double prime. Then on top of that, we have a p1 of x times u times y1 prime. So we will have a plus p1 of x times y1 prime. And then our last term also gives us u. So we have a plus p0 of x times y1. All of this multiplying u. This equals f of x. But notice this p of 0 p0 of x times y1 double prime plus p1 of x times y1 prime plus p0 of x times y1. This piece here that we just found as our coefficient for u, this is simply the homogeneous equation with y1 plugged in. But by design, y1 is a solution to the homogeneous equation. And so this whole piece is just equal to 0. So what we wind up getting is that last term disappears. And so we just have p0 of x, y1 times u double prime plus 2p0 of x times y1 prime plus p1 of x times y1 times u prime. This is all equal to f of x. Now, if we set u prime or v equal to u prime, then this becomes a first order equation in v. So we get a first order equation in v, a first order linear equation. In v. And so we have p of 0x or p0 of x times y1 times v prime plus 2 times p0 of x times y1 prime plus p1 of x times y1 times v is equal to f of x. Then we can use our techniques for first order linear to solve for v. Once we have done that, then we can use the fact that u prime equals v to solve for u. I need to update my screen. Again, we will use the fact that u prime equals v to solve for u. And then finally, we will use the fact that y is equal to u times y1 to solve or to find y. So this process is rather lengthy. The formulas for the coefficients in front of v prime and v are not necessarily the easiest to remember off the top of your head. So I recommend essentially reworking out these formulas each time we do them, simply by actually solving for y, y prime, and y double prime, plugging them in, and then rearranging the equation. If you're comfortable with it, you can use the formulas and jump straight to this point. Jump straight to this point if you're comfortable with it, and then you can solve the equation for there. So I'm going to have 2 more videos for reduction of order, and we'll go over 2 examples where we can use reduction of order to solve our equation.